you recognize this? This is a ground fault circuit interrupter. This is a device that's required by code that prevents you from getting shocked whenever you're using electricity and you could possibly come in contact with water. Whether it be your kitchen, your bathrooms, outside outlets, basement, garages, all of them require GFCI protection to keep you from getting shocked. I'm standing here in my master bathroom and there are 2 sinks and an outlet on either side. Neither one of them are a GFCI outlet. How does that work? Is it a mistake? I think so. I'm going to explain why and what I'm going to do about it coming up. If you need shade on your deck or patio this summer, check out Toya Grid Pergola Kits. You source the lumber locally and can assemble this modular system in as little as 30 minutes. Check the video description for links to videos and more information about Toya Grid. Now before we get started here, I just want to say I'm not really sure who's at fault here, whether it is the electrician or the builder or the architect. If you know the answer after watching this video, please let me know, leave a comment down below. Now in my kitchen, you can see this here is a GFCI outlet, and you can tell by the test button on it. That means it's off, and then I reset it and turn it back on. Now, an interesting thing about GFCI outlets is that that receptacle can protect another one. So you see how this one has these 2 green lights on it? That means it's wired correctly, but that means the power's on. If I come back over here and I click the test button, you see the lights off. This receptacle is protected by that one. Now I can also use this little device here. This thing is a GFCI tester that you can plug in. So I'm going to plug this in here. And I'm just going to push the little, well, first I'm going to push the power button. And then I'm going to push this GFCI test button here. And the click came from over there. But you can see the power is now off. Oh, by the way, this little device, really useful. It helped me figure out that I have an outlet in my garage that is not GFCI protected. I'll show you that at the end of the video. All right, now here in my bathroom, I'm going to plug that same device in here. And we can see that it says correct wiring, so the power is on. And I'm going to press the GFCI test button. Now notice it says open hot, and it basically says it's not energized. Okay, the outlet is off. Now, I didn't hear a click, did you? Now, this one over here is not a GFCI outlet either. Power's off on this one too. That means that these 2 outlets are protected by a GFCI somewhere else. This GFCI receptacle way over here in my main bathroom is on the same line. So I just reset that. That turned the power back on in the other bathroom. So if you ask me, that's pretty stupid. Why would these 2 receptacles in our master bathroom be controlled and protected by the bathroom that's got to be 40 feet away from here? I think that's crazy. If you had an event where it caused it to pop for some reason in here, why would you have to go all the way over there to reset it? We've also got a single point of failure now. If that GFCI outlet in this bathroom goes bad, it kills the power in the other bathroom too. You'd have no power in either one of the bathrooms. Now what I'm going to do is I'm just going to take a quick look. The power is still on. I'm just going to take a quick look and see which outlet is fed from that GFCI outlet in the other bathroom. And I can tell that by the one that has multiple wires. And I think it's this one. Yes, I would say it is the other one. There's only one wire in this side. So this one is going to stay the way it is. And I'm going to actually replace the other outlet on the other side. Now the power is still on, but I'm just very carefully going to remove this outlet. And I'm going to use my non-contact voltage tester so I can see they're both hot, obviously. Now I'm going to pop the GFI so that it's safe to touch. All right, there. Now I've got not energized, so there should be no power on here now. Nothing. Now I can disconnect this. After removing the outlet, I carefully separated the wires and I went back to the other room and I turned the GFCI breaker back on. So now I can test to see which one of those black wires is the one coming from the GFCI. And it's this one on the top. Now what that means is that's the line coming in to the new GFCI here. This wire goes to the other outlet on the other side. So when I wire the GFCI in here, I'm going to make this one will be the line, this one will be the load. And I'm just going to put a piece of tape on the line so that I know which one is which. That's the line. So let me explain what I mean by that line and load talk. So if you're going to connect multiple outlets to a GFCI, you have to know the difference. This here says line. I don't know if you can see it, but that says line. This is where power comes in to this receptacle. These contacts down here that have this tape on it, that's where the feed is going to go to the other receptacle. And here you can see it says load. Okay, line, load, power in, power out. Whatever you connect down here will also be protected by this GFCI. So I want the outlet over the other side to be protected by this one. All right, now I'm going out to the garage and I've got this breaker right here that says bath GFCI. That's the breaker that should shut off that GFCI in the other bathroom. All right, now I remove that GFCI and I can see this is the same brand. It has the line on the top and the load on the bottom. So I'm going to put all of the wires on the top screws so they all receive constant power. And the only thing that will be protected by this GFCI is this receptacle itself. All right, here you can see what it looks like. All the wires are on the top screws. The silver screws are for the white wires. The brass screw on the other side is for the black wires, and you can put both of them in because they are back wired. They go underneath this little metal thing underneath the screw. It's meant for two wires on each screw. So that's the way it should be hooked up, and that will provide constant power into the other bathroom. When wiring a normal receptacle, it doesn't matter, as long as you put the white ones on the same side, it doesn't matter which one goes to the top and the bottom. Same thing for the black wires on the brass screws. But when you're talking about a GFCI, the line has to be on the top. That includes both the black and the white. So I looked inside there and I can see these are the two that are coming in on the same cable. And these two go down on the same cable, and that's the one that goes to the other outlet. All right, here you can see the cable coming in here with the tape. That's the one that comes from the other bathroom, right? This one has power all the time. And that I put on the top screws. Those are the line. And then the bottom one is the load. That goes over to the other outlet on the other side of the bathroom. Now I'm going to turn the breaker on and test everything before I close it up. All right, with the breaker on, I'm going to hit the reset and put this in to make sure it is wired correctly. And you see two greens, that means it's wired correctly. And I'm going to pop it so that I know the power is off on this GFCI. Now I know the power is off on the other one. I'm going to test it And I still have power here, which means that I am powered regardless of the state of that other GFCI. All right, I put my little tester in here and hit the reset button, and you can see I have 2 greens, which means it is wired correctly. And on the other side, I have this tester, and here it says correct wiring. So I know both of these are wired correctly. Now I'm going to press this little GFCI test button, and you heard the click over here, and that one is now off. So I can reset it. And there it is, it's reset. And over here it's working again. So okay, 2 green, that means everything is wired correctly. Now, I don't know actually who makes the decision to only use one GFCI to cover multiple bathrooms. Would that be the electrician? Would it be the architect? Would it be the builder? But they only saved about $10 doing it. So I think it's kind of a waste, and that's why I think it's more appropriate to put the GFCI somewhere where the fault could occur. All right, let me give you a little bonus content here. So I have a GFCI outlet right over here, and I have another one behind that refrigerator. Now I happen to know the one behind the refrigerator is connected to the outlet behind that cabinet over there. All right, so that's fine. But over on this side, I have another outlet that I think the builder might have intended to be for an EV charger. So when I plug this in here, you can see it is energized. When I click the GFCI test button, guess what? Nothing pops. It keeps power. This is not a GFCI protected outlet. That's wrong. This is right here next to my garage door. That's really bad. Somebody could get electrocuted. So there's another problem I have to fix. What else is new? The irony is that this house is only 4 years old, so this is a modern house. So anyway, doesn't matter how old your house is, you're still going to find electrical problems, and you got to know how to fix them. Thanks for watching. Give this video a thumbs up if you liked it, and I will see you in the next one. If you are a DIY video creator struggling to find an audience, join HandyDadTV and get instant access to an established audience that will provide more views and income than you're getting on your own. Just go to HandyDadTV/join for more information.